Welcome to bilingual lectures for diploma students on the subject structural engineering, and it consists of 5 units. At present we are going to see unit 5, steel structures, and steel structures of course in the developed countries as well as underdeveloped countries, it is gaining momentum in the construction sector as well as in the developmental infrastructure sector, and almost in India 30 to 40% of the construction activities takes place only through steel structures. And the advantage of steel structure, as you all know, that it is having greater Young's modulus value as well as it carries more amount of tensile load. So, in that context this portion of content is introduced in unit 5, and after the completion of this lecture the students will be able to understand the various classes of IS code. Here I want to mention the IS code which pertains to steel structure, IS 800-2007, which works on limit state method. And after the completion of this subject, the students or the viewer will be able to know the various forms of hot rolled sections available in the market as far as India is concerned, and he will be able to know the concept of limit state method of design of steel elements, and he can design a tension member, he can design a compression member, he can also design a beam member, and at last he can also design the welded connections. And steel structure is an assemblage of group of members or elements connected together to act as a single unit to take care of all the loads which are coming over it. And the member in a structure is subjected to tensile force or a compressive force or combination of these, and a member which is subjected to tensile force is known as a tension member. Example, a tie member in a truss and a sag rod in a roof truss connected between the purlins, and a member subjected to compressive force is called a compression member. If it is truly vertical then it is called as stanchion. If it is of inclined position then it is called as strut. All these strut members you can see in a truss, roof truss members. And the structural steel used in general construction shall conform to IS 2062 and which has been classified on its ultimate or yield strength. For example, FE 410A means FE stands for steel and 410 stands for its ultimate strength, ultimate tensile strength, and A denotes the grade of steel. Grade A, grade B, grade C are being manufactured in India, and grade A steel is intended to be used in structures under normal conditions. Grade B steel to be used in structures where the temperature is not less than 0 degree centigrade, and the grade C steel is to be used between the temperature from 0 degree to minus 40 degree centigrade. And for every material which is to be used in a construction industry, the mechanical property plays an important role. As you all know that steel is very good in its Young's modulus or modulus of elasticity. The value of modulus of elasticity for steel is 2 into 10 power 5 Newton per millimeter square or megapascals, and modulus of rigidity or shear modulus value for the same is 0.769. It is almost 38 to 40% of the Young's modulus value, and the Poisson's ratio mu is equal to 0.3, and the coefficient of thermal expansion alpha is equal to 12 into 10 power minus 6 degree per degree centigrade. And all these properties are very important in designing a steel structure or steel structural element. And the method which we are going to design the steel structures or steel structural elements is a limit state method. Of course, previously the working stress method was used, and after the introduction of code IS 800-2007, all the structures which are being built in India by steel structures are to comply with the codal provisions of IS 800-2007, which is mainly concentrating on limit state method of design. And as you all know that limit state is nothing but the condition of a structure beyond which it cannot be used or it cannot survive, that is limit state, or you can also say that it is the acceptable limit for the safety and serviceability requirements before failure occurs. And the types of limit state of strength and limit state of serviceability. Limit state of strength it is nothing but the load carrying capacity of the main member mainly, and this include the loss of equilibrium of the structure as a whole or part, loss of stability of the structure or any of its members including supports and foundation, fracture due to fatigue and brittle fracture. And the other serviceability condition or limit state of serviceability which includes deformation and deflection, vibration in the structure, repairable damages, corrosion and durability, rainwater stagnation or ponding. This will happen in the sloping roof, probably in the asbestos steel roof trusses at the gutter portion. And actions, we used to call the loads here in steel structure design. Code specifies the actions are to be loads are to be mentioned as actions, and it is nothing but loads and their effects is mentioned as actions, and they are classified as permanent actions, variable actions and accidental actions. Permanent actions are nothing but self weight and the fixed components, fittings, equipments, etc. This will not change in due course of time or during the life period. And variable actions due to construction or service loads, wind loads, live loads, etc. are the variable actions. And accidental actions are nothing but the actions due to explosions or impact of vehicles, etc. And the very important definition is characteristic action, and the value is nothing but it should not expected to be exceed with more than 5% of the probability during the lifetime of the structure, that is called characteristic action. Then that means there is a probability of just 5% which is exceeding the characteristic action which is taken into the design consideration. And the very important terminology again is the design action. Design action is the action which is taken for the design of steel structures, and which is nothing but the product of a partial safety factor for the action and the characteristic action. And again there is a term partial safety factor. This partial safety factor for action is introduced to take care of all the undesirable or unpredicted deviations in the loads, that is partial safety factor. Of course, all these partial safety factor for various types of loads are given in table number 4 of IS 800/2007. And the next one is the strength of the material. Of course, strength is nothing but the load carrying capacity of the material. Ultimate strength, the ultimate strength is nothing but the maximum resistance that could be offered by a material before its failure. And the material usually in steel structures, or the steel material will fail by yielding or by buckling or by rupture. Of course, yielding is the flow of material within the cross section, and the buckling, of course, it is also the same effect. Rupture, of course, this will be turned into two parts, or சின்ன வார்த்தைகளை சொல்கிறதா இருந்தால் கிழியறதுன்னு அர்த்தம். ரப்ஷருங்கன்னா அப்படியே கிழியறது. யூஸ்வலாக வந்து ஸ்டீல் மெட்டீரியல் கிழியறது பார்த்துருக்க முடியாது, பட் ஃபெயில்யூர் வில் டேக் பிளேஸ் by rupture also. And design strength, we have seen the ultimate strength and the design strength. Design strength of the material is obtained by dividing their yielding or buckling or ultimate stresses by the relevant partial safety factor for the material. And there you have seen that design action is the product of partial safety factor and the characteristic action. You are increasing load, whereas here design strength, then that means you are dividing the ultimate strength by the partial safety factor of the material. And again the partial safety factor for the material, for yielding, for buckling, as well as for ultimate stresses are given in table number 5 of IS 800/2007. And again, for why this partial safety factors for loads are introduced? This partial safety factors are introduced for the unfavorable deviation of the load from the characteristic value. Probably there may be a little bit possibility of inaccurate assessment of the load and the uncertainty of the effects assessed. That is why the partial safety factors for loads are introduced, and the different partial safety factors are there in the table of IS 800/2007. And again the partial safety factor for materials, this is also for introduced for unfavorable deviation of the material strength probably the variation in member sizes along the length of the member, and deviations during the fabrications and errors in the calculations, etc. And the partial specific factors, and for the benefit of the students, and this tabular column is extracted from IS 800/2007, and the partial safety factor for the material when it is yielding, it is 1.11, and when it is in buckling, it is the same partial safety factor 1.1, and if the material is in ultimate stress, the partial safety factor is 1.25. And again, if the member is in of bolts and nuts, bolts and rivets connection, these are all the partial safety factor for the shop fabrication as well as the field fabrication. IS code books which are referred for the design of steel structures as far as within India, IS handbook to pick the values of the properties of the steel structural rolled sections, IS handbook number 1, and IS 875/1987 for taking the values of design loads on building structures, and it, as you all know, that it consists of part 1, part 2, part 3 and all. And IS 800/2007, this is the code of practice for structural steel in general building construction. And we all know that the hot rolled sections which are available in the market in the shapes of sections of rolled steel pipes may be of circular, square, rectangle, rolled steel angles equal or unequal, rolled steel T sections, rolled channels and I sections, sometimes called as beams. And again, the rolled steel channels are available in these forms, designated forms: Indian standard junior channel, Indian standard light channel, similarly Indian standard medial channel, and further I sections are classified as Indian standard junior beam, light beam, wide flanged beam, medium weight beam and heavy weight beams. And all the properties of all these sections are available in the steel tables, probably the geometrical properties, namely area, weight, depth, then width, breadth of flange, depth of flange, breadth of web, etc., etc., and the very important geometrical property, moment of inertia about the major axis and the minor axis, as well as the radius of gyration about the minor axis and major axis, section moduli about the major axis and the minor axis. All these values you can pick from the steel table, and also you can pick the values of plastic modulus and shape factors for the channel and I sections from table 46 of IS 800/2007. And we will slowly get into the design of tension member, which is chapter 1 in unit 5. And design of tension member, of course, design means you have to find out the suitable section for the given loading condition. That is the meaning of design, or the output should be, or the answer should be a proper section, a suitable section you must identify, that is the meaning. And the tension member, as you all know, that a member which is subjected to tensile force is known as a tensile member. And before we go into the details of the design of tension member, we must know how the failure of tension members occurs. And of course, these are the example of tension member. This is a roof truss, and the bottom chord member that is shown in blue line, that is nothing but the tie member, and other a sag rod between the purlin, this is shown in blue, that is called also a tension member. Here it is a tie member in roof truss and a sag rod in the purlin system, all the tie member, tension members. Again, these are all the examples for tension members. And failure modes, how the tension member will fail: failure due to yielding of gross section, failure due to rupture of critical section, and failure due to block shear at end connections. Failure due to yielding of gross section means entire area will be subjected to or will yield uniformly, that is and because of that yielding the member will get failed. That is the first mode. And the second mode, at the critical section, in the sense critical section means the area will be lesser than that of the gross section at that point of time, and at that area the stress on the other areas will be lesser than the stress at this critical section because of the lesser area. And as you all know that stress is the ratio between load and area. As the area decreases, stress obviously will get increased. So, in the sense all the other areas will be in yielding stress, and this part of the area will be in ultimate stress. So, at the ultimate stress the material will get failed by the action of rupture, or in other words it is called as fracture. Then that means கிழியறதுன்னு சொல்லுவாங்க இல்லையா, அந்த மாதிரி ரெண்டா கிழிஞ்சிருது. Then the other failure is due to the connection. At the member will be safe, but at the same time at the connection will fail due to the shearing effect and the tearing effect. Shearing effect na அப்படி slide ஆகிறது, ஒரு plane will be subjected to shearing and the other plane will be subjected to tearing in the sense tension. So, this is a small image which shows you the failure due to yielding of gross area. This is the member and these are the application of loads, and because of this pulling load the material in this full area will gets yielded, and because of the yielding the member gets failed. And always you remember gross section is denoted by the letter AG, A suffix G, and that is associated with yield stress. Wherever the area of gross section comes, you can blindly say that it fails by yielding stress. So, you can put Fy. So, yielding is denoted by Fy and gross section is denoted by Ag. So, the failure of course this is Ag and Fy, you cannot split this one, gross section Ag and the yielding stress Fy. And similarly the failure due to rupture of critical section, it is a small image which shows you the application of forces, application of a force which is the pulling force, and here they are dotted shows you the holes in the plate, 3 holes in the plate, and at that section the area gets reduced because of the holes. So, and the stress gets increased in this zone, whereas stress at this zone is in yield, whereas stress at this zone will be in ultimate. Then that means material will get rupture or fractured or broken into pieces at this point. So, that is failure due to rupture of critical section. Again I am repeating, critical section is the net section, net area of the section. There we have seen the gross area, here you are going to see the net area. So, when I say rupture it is ultimate stress, when I say critical section this is nothing but the net area. So, rupture ultimate stress means it is denoted by Fu, and the critical section means the reduction in the area, obviously it is denoted by An. And I repeat, here it is Fy and Ag, here it is Fu and An. And the third mode of failure is due to block shear, as I told you, and this is the image which is taken from the net, and these are all the bolt and nut connections of a member with a gusset plate, and you can see the bolt from this point, and again this point to this point which is in shearing plane, and the bolt from this point to this point which is in tension plane. So, shearing takes place along this bolts, rows of bolts, and again shearing takes place along this rows of bolts, whereas tearing takes place here from this bolt to this bolt. So, shearing plane is in horizontal direction in other words, and the tearing plane is in a vertical direction. So, now we have seen the failure modes of the tension member. One is by yielding of gross section, and the other is by rupture of a critical section, and third one is the block shear at end connections. And these are all the types of modes of failures. Now, we can see the types of tension members, and the types of tension members are wires and cables. Wires are used for hoisting purposes of probably towers, and cables are used in suspension bridges. All these two are used as tension members, and all these two will carry tensile forces. And again bars and rods, of course you can see that in all the reinforced concrete structures, and plates and flat bars, these are all used in transmission tower lines and footover bridges as a tension member. And again mostly the angle section is used as a tensile member in roof trusses. A single angle can be used as a tension member with one of its leg connected to the gusset plate, or if the loads are heavy then you can use double angle placed back to back on the same side of the gusset or on either side of the gusset. And again you can also use T channels or I sections as it is required, right. And these are all the just images to explain what are all the cross sections that are available and which could be used as a tension member. and these are all, this is a single angle, of course this is a single equal angle, and this is double angle, channel, I section, beam, and these are all the rods, cables, and these are all the built up section, and built up section is a section which is made up of two or more rolled sections connected together to act as a single unit to take care of the loads coming over on it. And these are all the connecting components that one must know. A gusset plate, a lug angle, and a splices. A gusset plate is a plate which is used to connect two or more than two members at a particular joint, and this plate is used, that is called gusset plate. And lug angles, of course, if the load is very heavy and the area required for a gusset plate is more, then that will give you an awkward image. So, to overcome that difficulty, lug angles are provided along the length of the existing angle, and this will give you an economical design. So, that is lug angle. And splices, of course, splices are nothing but the connections between the members. Then if you want to join two sections, then this will splice will replace the members of the joint where it is cut. Forces are received and abstracted from the member through the connection on one side of the joint, and it is transferred to the splice cover plate or angle section. And very important for the design, these are all the terminologies or definitions, even I can say this is very important. Gross area, net area, and net effective area. See, gross area is nothing but the area of the cross section of the member without deducting the area of holes in it. So, that is gross area. So, total area, in other words, total area is known as a gross area, which is denoted by letter A suffix G, and the area of cross section of the member, which is after deducting the area of holes in that section, is called net area of the member, that is denoted by AN. The whole area is AG, and the area after deducting the area of holes is known as net area, and that is denoted by AN, A suffix N. And the net effective area is the equivalent area of an imaginary axially loaded member of equal load carrying capacity, that is net effective area of the member. And all these three definitions and all these three abbreviations that you use, AG and AN, of course ANC, are going to be used in the design of tension members. And before we get into the exact design of tension member, we are supposed to remember the effective slenderness ratio of the tension members. The maximum value of effective slenderness ratio is 400 and the minimum is 180, and of course, all these values are there in the table 3 of IS 800 2007. Then the design strength of a member under axial tension TD, denoted by letter T suffix D, design strength of a tension member TD, which is the lowest of design strength against yielding of gross section, design strength against a rupture of critical section, and block shear at the end connection. And this is derived like this. This is the gusset plate, this is the gusset plate, and this is the member which is subjected to tensile force, and this is the gross area, this is a cross sectional area denoted by AG, that means the gross area. And if you want to calculate the design strength of the member, and as you all know that strength of the member is nothing but the load carrying capacity, from the basic definition, stress is equal to load by area. You can calculate the load carrying capacity by multiplying stress and the area. The same way the derivation is done here, and this is the design strength of the member under axial tension TDG, which is denoted by letter TDG, that is equal to AG into Fy divided by gamma m naught. And remember, this is the load, that is equal to area into stress. TDG is the load or strength of the member, that is equal to area into stress. That is all very simple to remember. And area here, because the material fails by yielding, so always it is associated with the gross area. So, I have put AG, and Fy yield stress is denoted by Fy, and the partial safety factor for the material under yielding is gamma m naught. So, Fy by gamma m naught is the design stress, this you have to remember. Fy always associated with gamma m naught, and again Ag is associated with Fy. So, it is simple to remember design strength of the tension member TDG, this is the load, TDG is equal to area into stress, that is all. Area is the gross area and the stress is the yield stress, which is associated with the partial safety factor for the material in yielding gamma m naught, and the value of gamma m naught is 1.1. And the units, of course, this will be in terms of Newton, and this is in terms of millimeter square, and this is in terms of megapascals or Newton per millimeter square, and this is a constant. And again second one, mode of failure, design strength against a rupture of critical section. As you can see here, this is the gusset plate and this is the member, and this is the application of tensile force, and this is a gross area, and in this member you have got two holes, and there of course the area gets reduced because of the holes, and the area here is the net area, and as you all know that gross area is the total area without detecting holes, and net area is the area which is obtained by detecting the area of the holes. So, now at this cross section the material will get failed. So, this failure or the load at which the failure takes place is known as the design strength against rupture of critical section or net section, which is denoted by the letter T suffix Dn. And again this is also load, tensile strength, in other words tensile strength against rupture of critical section Tdn, or you can remember this, T stands for design and this T stands for tension, and this is for net area, that is a critical section. So, we can coin this TDN also, design tensile strength against rupture of critical section, and again this is also the product of area and the stress. Area is the net area here, that is why I have denoted this as A suffix n, and the stress at that point is that the ultimate stress, that is the maximum stress, and this is the partial safety factor for the material at the ultimate stress, and that is denoted by gamma m1. The value of gamma m1 is 1.25. Again this you can remember very simply, this is load is equal to area into ultimate stress, and load into ultimate stress, again this ultimate stress is associated with the partial safety factor gamma m1. So, always if a material fails under critical under rupture or critical section which is associated with the net area and ultimate stress, this you have to remember. Whereas, in the previous slide, that is here, that is the material fails against yielding, you have got gross area and yield stress, whereas here it is net area and ultimate stress and relevant partial safety factor. I would like to summarize the lecture. So, we started with the introduction of steel and steel structures or development of the steel structures in India, and the various forms of steel sections available in India, and the parameters or the geometrical properties which are going to be used for the design of steel structures, and that you are going to pick from the steel tables or the handbook, and the design code which pertains to steel structures is IS 800 2007, and also we have seen the failure modes of the tension member. We will continue in the next lecture the other part of the content. Thank you.